All right, welcome everyone. This month we're just going to go through a couple of interesting tidbits in Python. I have it in a Jupyter notebook here. You can see we're going to start with structural pattern matching, which is one of the more recent additions to Python in 3.10. After the talk is done, we're going to fill in the missing components on this. I have just a rough outline, and the resulting notebook file is going to be available on the group's GitHub page. So github.com/OrlandoPython. So to get started, yes, we're starting with structural pattern matching. This is one of the two more hot button features that have been added lately. We're kind of just getting those two out of the way. You can see the next one down the page is the Walrus Operator, which I know people in developer circles have opinions on. Personally, I love it. I found a number of good use cases for it, and I'm just learning structural pattern matching and figuring out where to apply it in my own code. If you haven't heard of structural pattern matching, this is a very interesting use case of what in other languages would be called a switch statement. In Python before this hasn't really had a switch statement. It has just been utilizing if, elif, else clauses for its switching. However, with structural pattern matching, they brought not a switch case, they're calling it match case. And I'm not entirely sure of the semantics of it. It probably is listed in PEP 363, as you see right here. That part of this is based on. But the really interesting part of structural pattern matching is it's right in the name. We are able to match not only on the values, but the type and container, and even sometimes the search parameters of the values that we give it. In this example right here, I'm envisioning a video game where you have a number of locations in your game. So you can see we have a dictionary, we have a key of origin. Here's its display name, and here's where it's positioned inside of the game grid. And we also have a castle that is at 0, 2. I have a function right here called locate, and we can give it a value. I've specifically not added type annotations to this just to make things a little easier in this case. So we're just going to have it print out something based on the value that it is given. And we're just going to match on whatever the value is that we are given. Some examples that you'll see, maybe it will do split, or it will do some other item, change to it before you actually match on that value. And one of the really interesting things that I found with pattern matching is if you're giving it a dictionary of some kind, you can actually match it based on embedded values inside of your case here. So we're actually just going to say, hey, if the value that we're matching on, if it has a key in there called name and the value is castle, then go into here, we're going to print at the castle. And we can see that just right here. I'll uncomment this locate castle. Oh, I still had some stuff in there. Locations, origin, posts. Oh, wait a second. Okay, never mind. We're going to swipe this in here and rerun this again. So we've given it the castle location, and this is actually the potential pitfalls of running in a Jupyter notebook. Castle was an old variable, and I changed it into this thing. Let's just update it there. Should be the same. Yes. So we're giving it. I want to know, what is the locate me for this castle. It feeds it in. It hits this first case. We're at the castle because it matched a key value, and you can go further into this. So if we could add, instead of name here, maybe we were to add a field I'll just call it info. This can be another one. I know. There's a key in there. Well, okay. Now instead of name, let's check info, and we're going to match this if this location has a key instead. Come on. Can run this again. No, that should have worked. I'm still learning this particular bit of functionality. Anyway, I'll just pop this back. Oh, I know why. I added it to the wrong thing. This should work, but instead of giving it the origin, I'm going to move that castle, the key bit down into the castle. So that actually hit into our last thing here, unknown input, position unknown, because I gave it the castle, and in here, the origin has the info key. So if I move this down into the castle, the thing I'm actually feeding it, we should be able to run this, and we're at the castle. So it's not only is able to do things at the one level, you can go multiple levels into your data dictionaries and match certain values. Another thing that we can do is, this is if we're going to give this, this whole piece of information here, we can go into the dictionary. Let's say this value that we want to locate, we specifically want to match the origin. And rather than just giving it the origin, maybe this we're going to give this locate the value of our current player character. And that value is just going to be this XY coordinate. Well, we want to know, hey, if you're at the origin of the map, if you're just starting, we would like to know, we're going to say you're at the starting point. So if we feed it the 0 as to locate, well, we're at the starting point. Alternatively, we can use, we could just say, hey, maybe unknown input, and we'll just say you are at value, but we can do something better. Another thing that structural pattern matching allows us to do is to identify, hey, this is some kind of container that has 2 elements in it, and we're going to automatically assign them to the variables X and Y, kind of like you would do for a 4 key comma value in some dictionary items. It's the same sort of thing here, but the special thing with structural pattern matching is it will only match into this case if it is a tuple or a list of some other container that only has 2 elements. Something that's not shown on here, we could even just say, hey, and then we also, this must have at least 2 elements, and then any other elements get added into there are going to be put into this Z one as well. So in addition to just it has 1 element, has 2 elements, it matches this value, we can also do the same sort of tuple unpacking that we can do in the rest of Python, which makes this very powerful. But just going back here, if we give it some other non-special coordinates, so we're doing 2, -3, and we run this, it is matching this case here. You are at position X and Y, and we get that down here. Then lastly, in this example, if we pass it anything that doesn't match, this case underscore is going to match everything else that it is given, and we can come down here. So position unknown. Now, I believe if we just comment this out and we rerun this, nothing happens. So we can explicitly either have a default handling, or unlike some other languages, some languages require you to have a default, and then you can just default pass. Python doesn't matter. You can just not have a default case, nothing to handle the default case, and it just ignores it. So just to see all of that put together, if we uncomment all of these, we'll see all of them work. We're at the castle, starting point, some other position, and I don't know. And that is the gist of structural pattern matching. Now, before we get down to there, I'm going to clear all output here. Okay, the Walrus operator. This was introduced in Python 3.9. This also had some opinions about it because a lot of people felt it wasn't Pythonic in that we're introducing something that doesn't read like English, which I totally understand. Me personally, once I see that, it's like, okay, I know what it's doing. It's not that crazy a thing. And sometimes, and when you see it in person, it's like, okay, I can understand what this is supposed to be doing here. Other language, this is equivalent to what a language like Swift might have with if, let, and what would be called an if let clause. So what is the Walrus? The Walrus allows us to do conditional assignment. So the old school way of doing this sort of thing is, let's say I have a dictionary. I'm just going to say A is 1, and I'm going to be boring, say B is 2. And then somewhere we would do, let's say we have a value that we want to get, and we're given some input C. Now, if we were just to do D of C, we would get a key error because C is not in the dictionary. We solve this in Python by either handling the key error, or we can do the same thing but with get. If in this case, if the dictionary has a given key, it will return the value. Otherwise, it will return none. So I'll just go print the value here, and it's none. So we're not throwing an error of any variety. Another little thing that you can do here is we can actually just, we can also give a default value to get, but we're not going to use that here. Now, if we wanted to do something with value, only if the value existed, we might then do if value, or if we anticipated there are zeros in there, we may do if value is not none. Yeah. Print value is not none. And I'm actually going to put a little F stringy in there. So it's none, we don't do anything. What the Walrus operator allows us to do is, instead of writing this code here, we can just write if value, we give our Walrus operator, and then we do d.get, some value, and then copy this down here. So, and now I'll go ahead and change this over to A, and value 1 is not none. These are functionally equivalent, but to do the setup for this if statement to come into here, we need 2 lines. We need something to go ahead and grab the object and assign it to a variable, but then we also need an if statement to get into it. In this case, we're doing both of that on a single line into the if statement. Now, so we can see, hey, we have reduced a line of code and maybe some additional complexity depending on how this value is being determined or fetched. That's great. And personally, like with the Walrus operator, I can see, you can see what's going on here. You can intuit it. I still understand people not liking it because this doesn't read as English. You can't, like, if value equals, like, okay, well, if value Walrus equals, whatever. Totally understand, but the value to me definitely is there. Another thing I will say, where would you maybe not want to do this? The intended use of this walrus operator with the if value, if we want it to be pure readability or comparing to other languages, we would only ever refer to value inside of here. If we still then later want to come back to value outside of this if statement, then you probably do want to stick with the original method. But if you're only going to use this value inside of here, absolutely use a walrus operator. It's great. No questions? Moving on. Here's a fun thing. This is good. So the first two things that we've seen, these are built-in core pieces of the Python language. Structural pattern matching. These require having reserved words in the Python language. You don't need to import anything. These are just there. Same with the Walrus operator. Yeah, this is a full new operator into the language. For counter, this is one of those really interesting standard library pieces. This comes from the collections library or collections module, and it puts into a single line something that we have probably done at least once, which is counting the number of instances that happen either over time or we just have a list. In this particular instance, I am just kind of showing off how this works using rolling n number of 20-sided die. So just for the setup, this D20 rolls, we're going to sum up the value of rolling a 20-sided die n number of times. So you can see we're using the sum function, and we're calling random int for anywhere between 1 and a 20-sided die. If you wanted to make this 6, just change it to 6. But for this one, 20-sided die, because D&D, yay. And we're just going to run that n number of times, sum it all up, and return that value. We can put this into a list comprehension. So you can see we're going to roll this D20 5 times and come up with a list of n number of rolls. So the minimum number is going to be 6. The minimum number is going to be 5 in case we rolled 5 ones. And the max number is going to be 100 because we rolled all 5 20s. Well, if we wanted to then see how many times each of these results occur, we can just feed this into a counter. There are a number of different ways that you can populate this counter, but the simplest is just I have a list of values of some variety, and it is going to just add them up. If we wanted to do this the longer way, we'd have to do something like counts equals a dictionary for item in values. Try count item plus equals 1, and we accept the key error in case it hasn't been added yet, and we say counts item equals 1, and now we have counts. Cool. That does functionally work. It will give us I have seen the following thing n number of times, or we can import this counter from the collections library, and it does the exact same thing just by giving it all the values. And if we go ahead and plot this, have it import, and we run, hey, look, we we did one. We rolled one or one instance of rolling a 20-sided die 5 times, and that sum came out to 43. Cool. Let's add a 0 onto that. We've rolled 10. We now have 10 sums. Okay, well, we have a wider distribution here. What if we do this 100 times? Hey, look, we've gotten the same answer at most 5 times for a couple of things here. The really cool thing about this, rolling all these die, is that the more we add to this number, the closer and closer we get to a bell curve. Because I had to put something else in here to make it visually interesting. But yeah, if we roll a 20-sided die and sum 5 rolls, and we do that 1,000,000 times, well, guess what? We have a bell curve for the most statistically likely sum that we would get. Anyway, that's the counter from the collections library. There's a bunch of other modules in the standard library with things like this. We'll have at least one more example that came up at the last Lunch and Learn from another standard library module that's pretty interesting. F-strings. These are now an old friend, it seems, at this point. I think they were introduced in 3.5, maybe? Somewhere between 3.4 and 3.6. And F-strings are great, especially for logging. Now, what we've done in the past, we would print, let's say hello. Okay, well, we can print string literals, but if we want to put other things into there, we can do, let's say we got friends, and the print statement is pretty forgiving in terms of handling a number of arguments. It will just add them together. What if we want to do something a little more complicated, where let's say from datetime import datetime, and let's say now equals datetime dot UTC now, I believe it is, and we'll also give this now. Okay, it's not UTC now. Let's look at that up. Python datetime UTC. No underscore. Got it. Boom. Okay, so it was able to take this datetime object and automatically put it into the string for us. Great. If we wanted to add strings together, we can do things like that, or we can also go hello. We can start putting some of these brackets in there and call format, and it will just take the same number of arguments as there are brackets in the string. So same result. We could even you could also do things with the dot format, like I want to take 0, 1, and 0. So now it will take at index 1, at index 0, and index 1 again. You could do things like that, as well as I think like 2F or give me up to 2 digits. There are other formatting things you could put in there, but you would have to give a string and call format. If we wanted to do this as well, let me just get rid of these here. What an F string allows us to do is, instead of calling format, we just put an F in front of it. And now we just inline include whatever information that we want. And it gives us the exact same value. This certainly looks cleaner, at least to me. And we can still do other other things to it. For example, if I were to copy this, that for a second, we can still, do other things that we want to in here. So we took a substring of 2 into there. You can also do the same sort of things where, let's see, if instead of friend being foo, let's make this 2.5, something like that. I believe the syntax is it 2D or it's 2F? Yeah, so what is it? There. Okay, I need to look up exactly what the syntax is. But you can see that we actually have some extra formatting going on. All you need to do is put a colon after your variable name and then whatever the format code is behind it. And it will do the same kind of formatting as if we did here, 2F there as well. So same formatting, same sort of syntax, but now it's inline in the F string. There are also some really nice features, especially ones I find useful for debugging with F strings. If we weren't using a logger, the logging library in Python, and for debugging purposes, just printing things out to the console, maybe we would do, I would like to know now, and it prints it down here at the bottom. Okay, well, that's great, but maybe I have a whole bunch of these, and I want something a little more useful than that. Maybe I would do now equals, and okay, well, there I have now and it equals. With the F strings, we can do the exact same thing. We can give it the variable that we want it to print, but we can also put an equal sign after it, and it automatically fills in the variable name, whatever structure we give it with the equal sign, and then its value. The cool thing with this is, well, it no longer automatically converts it into the string representation or the string part necessarily. It converts it into its Python representation, which is a different Dunder method on the class, and we'll get to Dunders in just a second too. But we can also do, hey, I want, let's do from datetime, let's also add a time delta in here to have some fun. I'm going to do now plus time delta days equals 1. Well, now we can see now plus time delta, we are now 1 day into the future. So any additional things that we do to the value inside of this F string is going to appear in the printout along with the actual value. I think that is very cool. Then there are other things. I'll actually look up the syntax for this, but there are also formatting things for your datetime objects, your time, date, and datetime objects. I'm going to look this up. Python F strings datetime, because in format you are able to here give me the strf, ftrp, or ftrf format inside of the format string. Same sort of thing. Yeah, here's what I want. I'll just copy this. We can do print with our formatted string. We're going to give it now, but we are also going to give it the format, just like last time. The format bit starts with a colon, and now we can give it the format string, as you would see in the Python datetime documentation. And if we print this out, comment the other one, it is now going to print the F statement datetime according to this format string. So all of these together now, and these are all F strings. F strings are great. You definitely should use them. All modern versions of Python have this feature. Moving on. The rest of these should be a little bit shorter, maybe except for the Dunder. Context manager. This is another fantastic thing pulled from the standard library. The context manager comes from context lib. So we're going to do from context lib import context manager just to get it in here. And where would we use this? You've probably, if you've ever dealt with files before, you're probably familiar with, I would like to open a file. It's called it pyorl.txt as, let's just say file in or fin. Let's say lines equals file in dot read lines. I should probably make a text file so I can run this. Just say print lines. I'm going to very quickly to touch a text file in here off screen just for a second. pyorl.txt. Okay, so if I run this message file, I didn't do the. Okay. Okay. And now let's run this. Okay. Hello, Python people. So first line, hello, Python people, yada, yada. We've read in the contents of a file here. What's going on under the hood is when we open a file with a with clause here, there is a method, a hidden method on this resulting file object called enter, dunder enter. This would be on the class. And it's just getting called, and it returns a file object, or well, it returns a file object as when we go into the enter, the with statement here, it calls enter before our code runs. And after our code is done here, before we go to the print, it's calling another Dunder method called exit. And this is important because there needs to be some prep work on the file system level to get access, to unlock the contents of this file. We do something with it, we extract the information, and then when we're done with it, we need to close our access to the file contents. So all that has to happen in the enter. We do something exit. After that point, whatever we extracted from it is in memory. We don't need the file anymore in this particular instance. That's great, but maybe we don't want to do this with a class. This is where the context manager comes in. Rather than needing to have a class to have these enter and exits, we can do this to a Python function. So a great example of this is a timeIt function. And for here, I'm going to do from datetime. Oh, I already have date times on there, huh? So let's just do start. Oh, and this it takes a function. This is going to be important here. Oh no, never mind. No, it doesn't. I'm thinking of decorator. We're going to do datetime dot now. We're going to yield, and then we're going to do end equals datetime dot now, and we're going to print out end minus start, which should print out a time delta for however long it takes this to run. Well, this will be fine, but we need to do one more thing to this in order to use it. We have to do our context manager, which itself is a decorator. With this, we can now do with time it. Oh, and I'll even add some print statements into here. Yep. Print started at start and ended at end. And inside of our with clause here, going to sleep, we'll have it sleep for a second and print out of sleep. And I also need to import, from time import sleep. And this should work. I'm going to comment out what is not going to run. So you can see here, this is just our context manager. This is the code that actually ran here. With time it went into our time it function. It started at a particular time. We then yielded, which is a special keyword whenever we have one of these context manager implementations. This says at this point to go ahead and go into here to run whatever else we need to run. It then printed going to sleep. It then slept for a second, came out of sleep. After this was done, we went back to here where our yield is. We then ended at a time, and you can see it took just over a second for this to run. So in addition to just having the 1 second of sleep, technically this code took 6.4 thousandths of a second to run. And that is a context manager. You can do other things. If we wanted to do this with open as file in, if we want to do something more akin to that, maybe we would even yield the start, and then we could do as start time and then use start time somewhere in here. That's also totally valid use for a context manager. So I'm going to pull this back. Yep, all that good stuff. All right. Only got a couple more things here. I just want to quickly go over some class Dunders, some of the more useful ones. If you're not familiar with the term Dunder, that is just referencing the fact that these methods are special Python or special functions, or in this case methods, that interact with built-in Python functionality, and they are called Dunders because they both start and end with 2 underscores, or a double underscore, or a Dunder. If we have a class here, and I love oh, I don't even remember. Oh, treasure chest, class chest, and it has some items in it. Let's just say, so we're going to have a list of ints because we just care about the value of all the items in the chest or something like that. You're probably, if you've ever written a class before, you are probably familiar with at least one Dunder, which is our init, where we give itself and then whatever else we want to use in our function here. And just a list of ints, and then inside of here, self.items equals items, could do whatever else we wanted into there. Well, that's great. Okay. If down here we wanted to do chest and we wanted to, and let's say we initialize this with 3 items of increasing value, just 1, 2, and 3 to keep it simple. Let's go ahead and print chest. Very, very helpful information. By default, it's giving you where this object is located, or what file or module the object is located in. The name of it is an object, and then it's space and memory. Sure, but it's probably not as useful as it could be if we don't care where it is in memory. The first thing that you might do with a Dunder is we can call up the repr function. It still takes self, but it doesn't take anything else, and it returns a string. Now, you absolutely do not need to include any of these type annotations that you see here. They improve readability, in my opinion. And repr just returns a string, and we can copy the syntax if we wanted to by putting things in these angle break brackets. But let's like chest, say items equals, and you know what? Here's a great example. Here's a little convenient example of putting in an F string, wouldn't you say? Because then rather than doing items equals and then the items itself, well, in this case we can do self.items equals, and if we print it here, we got self.items. Now, if we wanted to clean this up, absolutely we could. It doesn't know what items are unless we did something like items equals self.items, or we just do chest items equals items. And I missed, self.items. Yes, that's the whole reason why we did that. So this is a way more useful printout for us here, chest, and then we just see the items in there. Now, we saw this a little earlier, like when we're printing out, ended at end, and it does this pretty, this pretty print right here when it gets converted into a string. Now compare that to, I want to see the value of now time delta. Well, that actually gives us the whole raw object, datetime.datetime, and here. If we, this is using the repr method, and this is using the string method, or str. Oh, there we go. Str, same sort of thing, self. It returns the string as well, just the use case is different. So rather than having maybe if we wanted to print out the chest, and it wasn't in some kind of a debug content, maybe we actually print, let's do chest with no angle brackets, and we'll give it the sum of self.items. So now when we print it here, it's chest of 6. But if we do an F string that you saw before, where we just want to see chest equals in this context, well, now this is now pulling the repr instead of the string. There's other things like enter and exit we saw before. There's also an asynchronous version of that called a-enter and a-exit. Not going to get into that sort of thing. There are a bunch of other things that you can use, like get item and set item, to treat it like a dictionary. Probably in terms of this chest, maybe get item and set item would be pretty good to have here. But I want to do something for to allow us to sort a list of chests. And there are only 2 things that we need. Like maybe, I think there's only one that we really need to do that. It really should be, but I think it really should be 2 just to kind of be safe with it. So this equals returns a bool, and it takes another object as well. And we can do return self.items equals this other object dot items. Now we don't necessarily know what this other object is, but in this limited example, let's just assume we're only testing against chess. There's a bunch of other, if is instance or has adder, and those sorts of, we can do those sorts of checks. But in this case, we're just going to do if the items are the same, if they both have items and the items are the same, we're going to say they're equal. The other thing that we need is to do I think it's a less than, so just Dunder LT. And this item is less than this other one if our self.items here is less than the other one's items. Now, I may actually have this flipped, and we'll see. We'll see that in just a second. So I'm going to say chest equals a list. I'm going to put our first chest in there. I'm going to create a new one that only has one in there, and I'm going to create another one. Oh, wait a second. Equals. Let's actually do the sum. That was my original intention. So equals there, and let's just say the sum, because we don't care how, maybe we don't care how many number of items, we just care about the value. So maybe just there are other things that we could do, like let's actually create a property here. We're going to call it value, the value of this chest. We give it self, and it's who is an int, and it just returns the sum of self.items. Cool. I just need to de-indent that. Now for this case, we can do rather than having to do the sum in here, we can just say, hey, this chest equals this chest if the value of this chest equals the value of this other one. Same thing over here. Now we're just comparing the sum value of these items. That makes more sense for this particular example. They've got 3, and let's say they got 8 in here. So in this particular instance, let's first just print chest. We have our original chest. We have a chest with 1 item and a chest with 3 and 8. So in this order, it's currently going chest 6, 1, and 11. If we call chest.sort, and we'll .sort sorts in place, sorted returns a copy. So depending on what you want to do. And we reprint our chests here, we can now see that this list is sorted 1, 6, 11. And I believe if I rerun this with these commented out, yeah, it says less than is not supported between instances of chest and chest. So in order to have the ability to sort this list, we do need to have these enabled. But then everywhere else in our code, we can just call chest.sort, and we get to leverage the built-in features of the Python language, which is great. Again, cool. Class method. This is going to be really quick, but it is another one. The rest of these are going to be very quick, so we can get finished up here. Class method is great if you find yourself constantly creating new classes from some value that needs to be computed in order to get the final result of your class. I find myself using this specific method a lot when using data classes from the standard library, or something like Pydantic. If you're doing models with Pydantic in Fast API, or any number of, well, and pretty much anything that uses Pydantic. So for example, let's say we have a coordinate, and I'm gonna do from data classes import data class. We can quickly just go over what a data class is with this example as well. data class coordinate. It has a lat float value and a lon float value, and that's all we need for a coordinate. We're going to say post1 equals a chord of say lat 10, and it has a longitude of negative 130. And we can print post1. Oh, oops. There we go. I now have a data class, and there's nothing there, but one of the nice things with these data classes, it automatically gives us a number of those Dunder methods, including our initializer, which just goes here. I used lat equals lon equals, but I can remove lat lon here as well, and as long as they're in order, then it also works. I'll change this around so we can have a different value as well. We'll call this post2, and we'll also go ahead and print post2. Cool. Now, what if instead of having these values, I'm getting strings in that look, let's say, coord string representation. It ends up looking like this, where I have some a string representation where coming in from an API, you're reading it in from an API, or you have an API and it's coming in as a some value on your URL parameter, something like that. In order to get the value out of here, yeah, we can do coord, let's say like lat lon equals our coord string, and we can split on the comma there, and then we want to convert our lat and long into floats of our lat and long strings. And now we can say post3 equals our coord of lat and lon. That works, but we have to do this for every time, maybe in multiple places in our code, just to see that it does work. Cool. We have a third coordinate, lat lon. What we can do instead is we can, because a data class is just a class, we can create a class method called, let's just like from string, and we take in the value. It is a string. Oh, and we do need to, the convention is CLS for class. Similar to how these methods we saw up here use self. Self is also just a convention. Self refers to the object that you were referring to, the instance of it, whereas CLS represents the uninstantiated cohort class. And we'll see what that means in just a second. What I can do here is we can copy this, or we can remove this code. We can pop it into here and just change. We're going to change this to value, and instead of doing this lat long bit right here, we can do we return a new instance of our class where lat equals the float of lat and lon equals the float of lon. So the class method needs to return it returns an optional instance of this class. You can also have it return none. If we were to get some kind of error in here, we could catch it and then return none. So either the string evaluated to a valid coordinate, or it didn't, and then you can handle that elsewhere. Down here, Now all we need to do is for post 3, we can do core.fromString. We pass it the value of our coordinate string, and we'll get the exact same value. Now we can use core.fromString or whatever other class method anywhere in here. And if you've used Python with, for example, the datetime module, we already used a class method. It's just a little sneaky, kind of, sort of. We had a datetime in there, and you saw for here we did now equals datetime.utc now. Well, UTC now is a class method, and it doesn't take anything because rather than saying, hey, you're going to give me a datetime, you're saying, I have called this class method, go ahead and get the time and automatically make it UTC and return that for me as a new datetime instance. And this is how you would do it. And that is class method. Raise from, this is exceptions, exception handling. So we saw earlier, we've had a couple of errors that have been raised because live coding, yay. We did see earlier when we were trying to access values from a dictionary that we had to handle a key error just in case. Now let's say that we have the same dictionary is still going to be value, just have value A and B in there. Now we can try to grab value of C, which again we didn't have. We handled that by doing d.get a value that we don't have to return none. But well, let's just let's run this as is. We have a key error. Now let's say we're somewhere deep in the bowels of our code. We want to be able to handle this explicitly. Accept key error, and we can say no key or something like that, and it will print no key. Well, that's fine, but if we're so down into our code, we run into an exception that we do want to handle, we can't just print it away. Normally, what you would do in this particular instance, you would maybe you create your own exception, and so I need to raise the exception. So you can see we tried to get C here. We got a key error, and we then raised a new exception called no key. And maybe this is some kind of custom exception. They're pretty easy to make, but it's kind of doing a little bit of handling for us, because during handling of the above exception, another exception occurred. This is coming here because we're in this particular environment. It may not necessarily always bubble up depending on the logging libraries that you're using, or some other mechanism like that. What you should do in this instance is accept the key error as exe like that. Maybe if you wanted to print, handle but print them out, maybe you do this, and you can see, hey, there's some kind of it got C as the print friendly version of this exception. If we wanted to include the error that happened and add on top of it so we can do some additional handling, we would do raise our new custom exception from the existing exception that happened underneath. Now we do get the same, so rather than seeing, here, take a look at the difference here. So during handling of the above exception, another exception occurred. These may be entirely different lines of things that failed. However, we do raise from our existing exception. We are explicitly saying The above exception was the direct cause of the following exception. We are explicitly stating because something failed, we are raising a new failure. Here's the full chain. It's a small distinction. It honestly, it doesn't take a lot to change, but it can really help. The larger your code, the code base you have, if you can say, hey, these are directly related because we added 4 words into our code, that can save you a lot of time. All right, we're almost to the end here. Suppress. Speaking of exceptions, this is another one of these great standard library little finds here. Suppress allows us to explicitly suppress and ignore certain exceptions inside a block of code. Well, just like we had here, we tried to access C from our dictionary that doesn't have a key value there. If we were okay with that happening and it doesn't really affect how our code functions, maybe we would write something like, hey, I'm going to try to get this value, but if you run into a key error, yeah, just ignore it. But if something else happens, raise, do something crazy, do something else. If you see this line in your code, if you are accepting something and passing on it, that is a fantastic use case to use suppress. So we're going to do from, oh, I'm forgetting, I think it's also context lib. From context lib import suppress. And what does context lib do? It allows us to make use of the with clause, just like we saw earlier with our context manager. So we can do with suppress key error. We're going to call the same thing, and these are functionally equivalent. And this is 2 lines of less code, except for the import. If you include the import, it's still 1 line of less code, and you're not putting passes everywhere. So same sort of thing. We ignored both times. We didn't get an error by running this code. Great. I love these little space-saving things. Also, more love to the with clause. It doesn't get enough love. Last little thing, you may have seen this before, but in case you haven't, we all know what a for loop is, hopefully. In Python, there is a for else. Other languages also have this. So we would do something like for I in range, let's say 10, and let's just go ahead and print I. If we run this, we're going to get 10 different printouts between 0 and 9. Now, let's say we were going through a list of items. Maybe we sorted that list of chests, and we only want to return the first chest that has a value above a certain number. So we can do for, let's say, for chest in chest. If the value of our chest is greater than 5, I'm going to say this isn't necessarily Couth Python, but technically, I believe we can still access chest out here, and it probably is not the same value as we had above there. Let's just see what happens. Yes. Okay. You may want to do this. Honestly, I wouldn't do this, but here's the thing. For chest and chest, if the chest, we're going to return the first chest where the value is above the value of 5. And we can print chest here. Hey, look, well, we got chest 6 in our sorted list of chests of 1, 6, and 11. This was the first one above a value of 5. Now, what happens if we want a chest that is greater than the value 20? That's not exactly what we want. Chest still exists. It is still a variable that we can pull from, but it just has the last value from our list because it never actually broke out of it. If we want to handle this, we can add an else clause here and just say no chest found. Please ignore. And in this particular case, no chest found, please ignore. It's telling us to ignore the printout down here later. The reason why it goes into this else clause is because we never break out of this for loop. So we will only go into else if nothing we did in here caused it to exit. If it exits normally, we will never hit an else. Very simple. I've found a number of places in code where it is useful, not just in Python, other languages too. But if you're just thinking, oh, else is the thing that goes on the end of my if statements, you may not think of putting it at the end of a for loop. Another place where you would have else that you might not think about it, we were just talking about errors. Everyone, I would say most people know about try and except. Well, there's also finally and else that you can put in that list. So we're going to try some code. If we run into, and you can also have more than one except. So if it's a bare except, it will just catch everything. We can put one or more errors to match with. You can do this a number of times as well, same sort of deal. To handle in this code, if this finally will happen after any I may be getting this backwards. Finally should happen no matter what happens here, whether it runs successfully or if we error, and else will only run only if there are no errors in the try. It's yeah, that's something a little different. There's just another place where you might not expect an else clause to come up. So we're getting to close to time here. I haven't seen any questions come in on the chat. If you have any questions, let me know. But that is the end of the 1, 2, 3, 4, 5, 6, 7, 8, 9, and even 10 features you may not know or may not be using in your code that I think provide a lot of value.